Touchscreen devices are often designed with ability assumptions, including the ability to perceive visual information, locate the target button, and precisely perform the predefined gestures, which make these devices inaccessible for users with diverse abilities, such as visual or motor impairments. We introduced BrushLens, a hardware interaction proxy designed to make touchscreen devices more accessible for people with diverse abilities. BrushLens is a hardware device that is wirelessly connected to the user's smartphone. It can be attached to the smartphone as a phone case, and uses an array of solenoids covered with conductive fabric to actuate the screen. When activated, each solenoid can punch the screen, thereby simulating the touching gesture. Using the smartphone camera and the IMU data, BrushLens can perceive the interface and precisely determine when to touch, allowing users to brush on the screen and delegate the precise actuation to the system. We demonstrate two possible actuator setups for BrushLens: solenoid and autoclicker. The solenoid actuator can push the touchscreen to simulate finger touches. This allows solenoids to be compatible with various touchscreen types, such as capacitive touchscreens, resistive touchscreens, and physical touchpad. The autoclicker actuator alters the capacitance of the screen to simulate a fingertip touch. With no mechanical movement for actuation, autoclickers have lower actuation delay than solenoids, resulting in better actuation accuracy on capacitive touchscreens. All actuators are controlled by the BrushLens software, which calculates the device pose from sensor readings and decides when and which solenoid to activate, given the saved interface layout and the user's command. Using their personal smartphones, users can explore the touchscreen and command BrushLens through an accessible interface. We demonstrate three different modes for various interaction needs: screen reader mode, button magnifier mode, and the interaction routine mode. Screen reader mode. This mode projects all buttons from the current interface to the smartphone interface. Visually impaired users can use the screen reader on their smartphone, such as VoiceOver, to explore inaccessible touchscreens. BrushLens uses a grid system to map the screen locations into cells. Once the user selects the button they want BrushLens to press, BrushLens will speak out the target coordinate and BrushLens' current coordinate for movement guidance. Button magnifier mode. This mode enlarges and displays touchscreen buttons currently around BrushLens on the user's smartphone. This mode makes smaller or densely packed buttons easier to select, which reduces the need for fine motor control and the risk of mistouches for motor impaired users with tremor or spasm. An additional handle can be added to the extendable slot on the case to support different grasp preferences. Interaction routine mode. BrushLens can save a sequence of input as an interaction routine. Instead of exploring each interface and clicking buttons one by one, this mode allows users to quickly actuate a sequence of buttons, such as ordering a saved list of items or typing password, to speed up the interaction. Our user study shows that BrushLens enabled visually impaired users to interact with inaccessible touchscreens across various interaction tasks, reduce incorrect touches by up to 73.9% for participants with tremor or spasm, and give users a sense of control over the proxy for actuation. We envision that BrushLens could support a broad range of interaction needs, reduce the risk of unintended interactions, and enable individuals with diverse abilities to benefit from BrushLens across various daily scenarios.